Move aside, everyone. I'm a professional orange doctor. Bring the oscilloscope. Don't worry, you're gonna be okay. Just need to check you. It's gonna work. Disclaimer: none of the made-up doctors or oranges were harmed during this video. And now, we are not going to talk about the cardiogram of this orange or how to read it. However, we can talk a little bit about this oscilloscope. Oscilloscope is a device that helps you to visualize the electrical signal that you are measuring and then helps you with the system analysis. This oscilloscope is a digital storage oscilloscope. It means that it can store all the data that it gathers about the signal that you are measuring and then to display it, and we can analyze it while it's displayed. The advantage of the digital oscilloscope upon the analog oscilloscope is that you can save the data. After you save the data about your signal, you can display it and analyze it. Yes, analog oscilloscopes cannot do that. They are displaying the signal in the real time. Let's go through some of the main features of the oscilloscope. This one has 50 MHz bandwidth. This means that we can measure properly, without any distortion or attenuations, signals that their frequency is up to 10 MHz. This probe can display frequencies up to 70 MHz without any problems. Yes? Before you are getting started to measure anything, make sure that the probe is calibrated properly. Let's discuss about those three big knobs that we have here. Yes, this is the horizontal knob. It is responsible for time per division. Yes, when you are controlling it and turning it, yes, it will increase or decrease the time per division. It means that when you have a high frequency signal, you would like to decrease the time per division so you can zoom into the signal. If you have a low frequency signals, you would like to increase it so you will be able to see the whole signal. The other two knobs, one per each channel, are controlling the volts per division. It means that if we have a signal with a high amplitude, we should increase the volts per division. It means that each division will be represented by a higher voltage. If we have a signal that has a small amplitude, so it means that we need to decrease the volts per division in order to display the signal in a good quality. And it actually very matters, you should control those. For instance, if we are controlling here the vertical line or the volts per division, we can see right now that the peak to peak is 3.28 volts. To make it more accurate, we can decrease the volts per division, and we can see that actually the volt peak to peak is 3.14 volts. Let's see what will happen if we will increase the volts per division. Right now it's on the maximum and the volt peak to peak is actually 4 volts. So what is the correct voltage? Is it 4 volts? The proper voltage of this signal is about 3.14 volts and not 4. Why? Because we have scaled the whole signal to fit into the screen, and this is the most precise measurement that we can do. Another important thing is the trigger. The trigger makes sure that the time base starts from the same point every repetition of the waveform, and then we can see that the wave actually stands and not moves around. Most of today's oscilloscope have also other features such as FFT. They can add and subtract between the two channels. You can point a cursor there, you can measure it by itself, like we can see here, the volt peak to peak, you don't have to count the divisions, and many more other features.
Don't forget to subscribe to our channel, leave a like, leave a comment, find us on Facebook and Instagram. See you in the next video.